this is located inside our STM32. It's located inside CMSys device STM32F4XX source folder. So the include folder, we know the include folder already, header file for all the STM32F versions. Okay, and we saw that this has the definition of our peripherals like we did in our structure lesson. Okay, so we can just do this and keep the source folder with a template there. Whenever we need it, we can come to it. Okay, so I'm going to come back here to the drivers folder where we started. And then we have all drivers here. We don't need HAL. Again, let me come to the very back. This is the package we extracted. Now it's called just the drivers folder. Inside the drivers folder, there is HAL driver. We just delete HAL. We don't need HAL. We say yes to delete. It's going to take a while to delete. Okay, so this is the package we extracted. Now it's called just drivers folder. Inside drivers there is CMSys, and then inside CMSys there is core. Inside CMSys core we have this include that gives access to all the Cortex M processors. And then when we come back to CMSys and we go to device and then we enter ST, we have F4 over here, and the include folder here gives us the header file of all STM32F4 boards. And then when we come back here, we know the source here gives us a template if we ever want to create a type of system underscore STM32F4, which I call the startup.c file. If we ever want to create that, we can use this template. Okay, we come back to our CMSys folder. We have include here, and this include, okay, this the include, there's this include folder here. Let's compare it to core. It's just appeared as if include looks just like core. Okay, so the include folder and the core folder appear to be the same thing, so we can delete core. Actually, I'll open this, we compare it, open in a new window. Just bear with the process here, just bear with me, and you wouldn't need to go through all of this. I'm going to upload the final folder once we've cleaned everything. Another way, rather than cleaning, we could have just copied the header file we require. Based on your board, you need just your Cortex M4 and then your STM32F411. In my case, it is F411, and you'll be good. As you saw, we created a project without having any header file, so it's not like we need all header files here. Anyway, this is the core folder, right? Inside core, there is this include folder. I'm going to compare that to the include folder we have in our CMSys, and it's exactly the same. So what we're gonna do is I'm going to delete the core folder. Open this. I'll delete this permanently. Okay, so what we have left is the device, and we know when we enter the device we'll go to ST and then we'll get access to our STM32F4 boards, and then the include here will give us our Cortex M.h files. Okay, so now this folder here, I'm going to, remember I said because it's 2 GB, I extracted at a different location, so I'm going to copy this folder, or what is left of it. This is the package we extracted. Now this is what is left of it. It's called drivers. Okay, let's enter drivers. What is inside drivers is CMSys. I'm going to copy this CMSys here. Okay, and I'm going to come to our workspace and I'll create a new folder here. I'll call this chip headers, meaning header files for the chip. And inside here, I'm going to paste the folder. Okay, so yeah, just bear with the process. I apologize that it was a bit not too straightforward, but yeah, I'm going to upload this chip headers folder to the lesson, to the video, so you can download it. All we need is our STM32F4XX.h file or STM32F4 f411.h so that we can have the structures just like we created the structures. We want all the structures already created for us. Anyway, so let's come back to our IDE. I'm going to make a new project here by making a copy of our previous project. Or actually, to show you this, I'll just create a new project from scratch so that we see how we would go by this. I'll say new STM32. So we select our MCU. I'll say STM32 F411. Over here is this version. This is my board F411RE. So I'll say next. And then I'll give the project a name. I'll say number 2 GPIO output. And then I'll say empty project. And then finish over here. It's creating. Okay, so once that is done, I'm going to link our chip headers. I'm going to copy the path over here. Right, and I'm going to come over here to our project. I'll right click. I'll say properties. And then I'll come to C, C++ general. I'll drop down over here. I'll select paths and symbols. And I'll come over here under includes. I'll click add over here. And then I'll click file system. And I'll paste the path to our chip headers folder here. And then once I'm in, I'm going to enter CMSys. I'll start with device, ST, STF4, and then the include folder. And then I'll say select folder. And then I'll say OK. And I'll do that again. I'll click add file system. I'll come back to our chip headers. I'll enter CMSys. This time I'll go to the include and then select folder. And then OK. And then apply and close. I'm going to open our main.c file here. I'll clean everything, Ctrl A, and then clean. So I'm going to start off by including our STM32F4.h file. I'll say over here, include STM32F4 xx.h. And once that is done, I'm still going to give the symbolic names. Remember, we said GPIO enable. I'll say define over here. GPIO A enable is just shift 1 to bit 0. And we said LED pin or pin is pin 5. So I can define pin 5 here. Just like we did previously. This means shift 1 to position 5. And then we did also define LED pin is pin 5. Okay, and then int main takes no argument. And then we have our infinite loop here. While 1, open and close. And then we start off by enabling clock access to GPIO A. And we said we do that by going to the RCC module. So I say RCC, I use the arrow operator and then AHB. So there is something we have to take note here. When I did RCC arrow, I was expecting to see the list of RCC registers appear. Since it didn't appear, either our include is not complete or we need to build. So I'm going to comment this out and then build a project. It's building. Let's build again because I want you to see the error that happened. Okay, so error, it says over here, please select first target device used, because inside this file known as STM32F4xx.h, this is the generic file for all STM32F4 chips. Mine is F411, yours might be F40 something. So you need to decide or say which one it is. Let's enter this file. I'll double click, right click, and open declaration. Okay, so over here, when we scroll down here, it tells us what to do. It says over here, if defined STM32F40XX, then include this header file. It would automatically include this if we define this. So to use my board, STM32F4, I would have to define this STM32F411XE. When I define this, then the header file for F411xe.h will be included for me automatically. So I'm going to double click this and Ctrl C to copy. And then I'll come to my project again, right click, properties, and C++, general, parts and symbols. I'll come to symbols here and I'll add a symbol. I'll click add over here and then Ctrl V to paste, and then I'll say OK. And I'll say apply and close. Then I'll close this file. Now I'll build again and see. Okay, now everything is perfect. Okay, so let's enable clock access. We go through RCC arrow operator. I still don't get all the registers. Okay, let me type AHB, AHB1 ENR. We want to enable clock access for GPIO A. Let's build and see. Okay, it's working. So although the IDE did not list all the members of the RCC structure, it doesn't mean it couldn't locate it. Okay, so we've enabled clock access just like we did in our own, when we did our custom structure, we did this exact thing. After that, we'll compare the two. So once we've done this, we need to go to the mode register and then set PA5 as an output pin. So I'll say GPIO A mode register by saying mode R, and then I'll start by setting bit number 10 over here to 1, and then I'm going to set bit 11 to 0 by having the end and then the tilde over here to invert it. And then once that is done, we came here to make the LED toggle GPIO A. We access the output data register and then the toggle operator, which is shift plus number 6 on the keyboard, and then this equals LED pin, and then we said it's going to be too fast, therefore we put a delay, a pseudo delay if you may. Int I equals 0, I is less than 100,000, I plus plus. Okay, so let's build this and see. I'll click here to build. It's built successfully. I'll get this onto the board by running. I'll click over here and then I'll say OK over here. Okay, it's downloading onto the board. As you can see, the LED is blinking and working exactly the same way. So let's compare this to our previous project. Remember our project LED toggle underscore struct, LED toggle ADDR underscore struct. I'm going to open the main.c file in this project, main.c, and I'm going to drag this and then put it side by side with our current main.c. Okay, so that's what we have. So we simply included this file and we didn't need to create our addresses, and then we didn't need to create our structure as well. But if you see the main.c, it's exactly the same thing. We started off with this to enable GPIO A and then mode register, the same configuration. In fact, if we copy and paste, nothing would misbehave. It would work exactly the same way. But again, the reason we needed the header file is because we don't want to always create these. And remember, this is a very short version of the structure. It was really long. And when we start working with more complex peripherals like the ADC, we would even see bigger structures. So the header file here provides us with all the structures already made for us, and we can just access its members and then we configure the registers using this method.